All right, here's a lesson on transforming polynomial functions. So in a previous chapter, we worked with transforming quadratic and linear functions, and I did cross out that we won't focus on horizontal stretches and compressions. So in this table, it shows you the first transformation. If we do a vertical translation, what's going to happen is we're going to have a plus or minus k. So that happens outside the function. So if we have a plus 3, it's going to move up 3. If it's a minus 4, it'll move down 4. And that's when you have a plus or minus k. For horizontal, that happens inside the function, and I say think opposite. If you have a minus 2, think opposite, you're going to move right 2. If you have a plus 1, you're going to think opposite and move left 1. Vertical stretches or compressions happen in front of the function. They're going to be multipliers. So since that a is greater than 1, it's going to stretch by 6. It's going to be taller, skinnier. Now we have an a of 1/2. It's a compression, it's a fraction. So those make the graph wider. The last set is reflections. There's 2 reflections. If we have the negative in front of the function, it's going to reflect across the x-axis. If our negative is inside the function, see the difference here inside the parentheses, it's going to reflect across the y-axis. So here's an example. We're giving you a cubic polynomial. So here's our cubic. And we're going to describe the transformations. So the first thing is we have a multiplier of 2. That's our a number. So our a is 2. So how we describe that is going to vertically stretch by 2. Then we go inside. This is a plus 6. So we have to think opposite. That is our h. So it's going to move left 6 units. And then our last one is outside the function. That's our k. And what that's telling us is a positive k, so it's going to move up 7 units. All right, here's a new polynomial. It's another cubic function. And what we have is a negative in front of the function. So if we go up to our table, a negative in front of the function reflects it across the x-axis. Then we have a minus 3 outside the function. That's our k. So if we go up to our table, that is a minus k, so it's going to move it down 3 units. All right, another cubic function. First thing that happens is we have a multiplier of 1/3. That's our a. Our a is a fraction. So what happens is going to be a vertical compression by 1/3. Then we have h, so that h is telling us it's going to move the cubic function to the right 2 units.